All right. Hello, welcome to my final report for graphics. Um, my name is Murray Campbell. I will be your host today. We're going to go through this and just talk about everything in the final project. I found the grading rubric and not the grading checklist to be just like the most useful bit of notes for me to go through here on this video, so I'll just be kind of going down this list and then talking about the classes, anything I forget. Yeah. Anyways, so first off, I'm just going to show basically the completed demo, show that off for a bit. I'm using my other computer now for the first time, so this should be running really well. Yeah, anyways, okay, so you see what we got here. This demo is just meant to showcase some of the pre-made models, various shaders. We have just like color shading and texture shading. It's meant to show off lighting. My lighting model has support for directional light, one directional light, one spotlight, and 3-point lights. So you can see the 3-point lights going around these little UFO type things. They're just tiny frigates that are kind of rotating around the scene. I guess I wanted to make a little UFO scene, kind of. I don't know. Here's another ship. It's crashed. It's a ruined ship. I don't know. I use my imagination with what I had in the project. It's kind of funny, though. I'm showcasing Skybox here, so you can see that works. Not to mention Fog. Fog works. Although it looks different for everything. It's kind of funny. And this is so weird because like scaling, man, like scaling affects everything. You want to have like stuff at like just uniform scaling and scale it in the models themselves. Otherwise, it's just like impossible to get things to have unity in how certain things work. But yeah, anyways, here's my the texture's kind of weird. It's got these little seams, but yeah, my skybox looks like this. Pretty normal. My terrain is lit. I have a basic little terrain texture on it, and then I'm using the test height map. I've got this little black obelisk type thing, pyramid, and then a colored cottage with color shading. You can see the lighting working on that, and then like a 6-face box texture. All of that works basically. So yeah, I guess that's my demo. That's all I really need to show in that. So now I'm going to go through all of the classes through the checklist and stuff like that, just to show you that I got everything. So first off, the pre-made models. We'll just start off. I have the box, the pyramid. I've got the box, the skybox, the pyramid, and the unit sphere. So yeah, all of these work. They all have their respective normals, except for like just the unit. The unit box has its normals because those I knew what those normals were, but the pyramid doesn't. Yeah, that you said that wasn't required, so that yeah, they don't have that. Yeah, this is kind of straightforward. Standard vertex stuff is correct. It's like the most updated version. Allows you to set things and sets default values for stuff if you don't specify certain values. Yeah. Skybox has just inverted faces. We got the pyramid, the unit pyramid, and then the unit sphere. Cool, all of that. As far as external models go, I can just showcase that. I just showcased that they were being used with the cottage and the frigate multiple times. So models are pretty simple in this thing. Here, let me just find the model. Here we go. P model cottage. Let's make this bigger. P model cottage. You just specify the Azul file and P model frigate, and it'll construct things like that. You're able to set texture and color independently for each mesh, and I kind of showcase that. Both my color shader and my texture shader offer that feature. So you can kind of see my cottage, I set different colors for each of the submeshes in that to make it look a little more like a house. Moving on. We have the shaders. Yeah. Work in 3D, implement fog lighting with multiple lights. Implement spherical fog with user-provided parameters. So let me show that off. I have those shaders. I've got color multi-light and texture multi-light. These are the two main shaders that I use in this this demo right now. Okay, so it has the Fong lighting model on it. You can see that it's got access to 3 point lights, 1 directional light, and 1 spotlight, and it can calculate all of these. It has a constant buffer for fog parameters that gets passed in. Then these are the computation functions that you gave us. These are pretty straightforward. Going down here, we compute these lights using the functions that we specified above. I compute the point light, the 3 different point lights basically, and then calculate the fog, which is a lurk between the whatever the lit color is and a user specified fog color. Then it returns that. My texture works pretty much the same, except it's got a texture applied to it then. Same sort of deal here. We got 3 point lights, a directional light, and a spotlight. A constant buffer for fog parameters. These compute point light, directional light, spotlight functions. Texture handling. All of these pretty much the same as the color, except now we're calculating the lit color, and then we're multiplying by the main texture. We're sampling the main texture immediately after the lighting. We do that before we do the fog because we need to. Otherwise, this doesn't work. I tried putting it after, and it was bugged, and it didn't look. The fog didn't render. Obviously. So fog happens last. There's that. Yeah, so that's the shaders. Let me show you the shader classes themselves. Not all of these are relevant, but I'll just show the most important ones. Obviously, we got the shader base class. I'm still storing the fog parameters in the shader base class, but that's only because you don't need to specify the fog parameters, and it'll, if you don't do that, then it just won't do fog and it won't calculate it. So it doesn't seem like that huge of a deal to me. It was just an ease of use thing to remove, copied code. Yeah, the shader base class functions more or less how we've talked about in the past classes. What's important is my shader color multi-light class and my shader texture multi-light class. So we'll start with the texture this time. Just want to see what time I'm at. Cool, 10 minutes. Straightforward. We have functions for the user to access to set information in the shader, such as setting the directional light parameters, the point lights, A, B, and C, and then the spotlight parameters. Then there's a function to send fog parameters as well, but that gets called by the graphic object, and you'll see that soon. These various structs and references to point lights and the various lights, and then the buffer for the fog parameters. And in the actual shader CPB class, you can see we're accessing the texture multi-light HLSL file, sending up the various buffers, setting them up at least, the various light parameters, fog parameters, zeroing out the memory, stuff like that. And we have the functions here, which basically just set these structs. But when we actually send them up in the send light parameters function. That's done through the update subresource function here. Send fog parameters does the same thing as the send light parameters. It just sends the fog params up to the shader. So this is what handles that, and then the set to context function sets the correct buffers in the correct order as well that they are in the shader. So that's how that works. And then the color multi-light is pretty much exactly the same. It is, I think, exactly the same. Yeah, that's it. Yeah, there's pretty much no difference between this and the texture multi-light color. It's just accessing a different shader, obviously. Okay. So there's that. There are the shaders. Let's move on to, I'm going to do the graphic objects first, because that's just like the relevant extension of this, because the shader classes feed into the graphic object classes. So let me go to my graphic object color multi-light and graphic object texture multi-light. So here, this is where things like the texture and the colors are held and set. Light handling is done in the shader, obviously, but for each individual graphics object, they need references to their world matrix, the shader that they're invoking, obviously, and then the textures for the texture, at least for the texture multi-light class. You can see in the constructor we pass in the shader and then we pass in the model, and that sets various. In the graphic object base class, we have references to the model, and that's why we need that there. So we do that. The textures are a pointer to, or they're an array of pointers to textures. The texture class doesn't actually handle its own textures. It basically, those get passed in. Well, actually, they don't. Yeah, they get passed in these functions for set texture. But the deleting of textures is up to the user, because the user needs to specify those textures. They need to create them and all of that and handle them themselves. So that's left to the user. We just get access to them. The only other important thing to note here is in the render function, we send the fog parameters first. We bind the index buffers after that, and then we go through each individual mesh. I forgot to mention that these have support for multiple meshes, so you can set the texture for all of the entire mesh, or you can set the texture for individual mesh nums, right? And then in the render function, it just goes through all of the meshes and tells them to render using the model's render mesh class. which renders an individual mesh. So this will render the entire model, it just does so on an individual scale with each mesh of an object, of a model. You can see that we're also setting to context the mesh textures. So that all gets handled here. And I'll show off how that basically works in a bit right after this in my DXApp class. Moving on to the color multilight class, nothing super different about this, except we just have references to the colors, and I do this through the ambience, diffuses, and speculars. I've got a pointer to I have an array basically of these values here, because these are material values, and the color class works. The color light class works with materials. You color stuff through the materials. So I've got an individual array. Instead of making a struct for material and risking align 16 errors or warnings, which I would get if I did that, I just had an individual array for each like ambient, diffuse, and speculars. And this works because when you're working with meshes, one mesh has its own ambient, its own diffuse, and its own specular, and you can just put in the mesh num and it'll be the correct index for that ambient, diffuse, or specular value. So same thing here, we have a reference to the shader color multilight shader, stuff like that. You pass that in, and you pass in the model as well. It's pretty much exactly like the texture class, except now we're setting up these material arrays. I set them with default values, but then you can set them to whatever you want afterwards. And it obviously supports, you know, setting the entire models as one material, or set each individual mesh of a model as a specific material. This class handles its own colors stuff, so I do delete those arrays at the end. And after that, it's pretty much the same thing. I send the world and material up in each individual mesh and tell the mesh to render. And that's how that works. So just to show off some of those in action, because those are kind of the meat and potatoes of the engine here. Basically, I have a bunch of references to models, their corresponding world matrices. You can see that I do that for all my objects. I have one model. If I'm doing rendering multiple objects, I'll just specify one model and then do multiple matrices for the multiple world matrices, because then I can just render it like 3 times or whatever with a different world matrix and set the world matrix. So that works out like that. I have a reference to light positions because those get updated. My terrain is here, and I'll talk about my terrain class in a bit. And you can see I have my shaders here. The skybox shader has to use the shader texture class. That's just because I don't want it to be lit. So that's kind of designed for that. Then you can see my references to graphic objects, and these have to be individual objects, obviously. So I have my cottage, the skybox, the textures for the skybox and the terrain. All of the textures that I use are underneath the graphic objects. You can see the 6-face box, the frigate, the pyramid, and then those 3 frigates. The name of this is unit sphere. They were spheres for a while, but I turned them into frigates so that they could be little UFOs that go around. I just like the way that looked more. Let's see. That's it as far as references. Then you can see I just set them up here. I have my shader. I set up all my shaders first. I set the point light positions, the directional light parameters, all of the lighting parameters. I set the fog parameters for each shader individually. These have to be specific for the shader because of scaling stuff. Then I have I set up my models, and I set those up with obviously like the models and the textures. So I just access those files directly like that. I also have some pre-made models that I'm accessing here, which is really simple. It's just the same thing as a reference to a file path, except I'm referencing now this enum that is internally referencing a function that creates these pre-made models. Then I set up my graphic objects after that, and those get these references that I set up here. So the model, the shader stuff, the pyramid set up like that. I set the material of that. I do the cottage this way. I set the textures on the frigate, the 6-face box. You can see that I'm also setting the color, the materials of these UFOs. Those are just meant to be black, but because of scaling, the fog makes them blue. And they're so small that the fog is messed up. That's my lesson from this, I guess. Is just like never scale things. Then I set up my skybox and the terrain after that, and I'll talk about those later. Like I said, I set up my world matrices. Yeah, pretty much straightforward here. This is just positioning and scaling stuff. So that's the init demo. It's all just set up, which is what we wanted. And it looks really nice. Then in my scene, I update positions of the UFOs. I also update these pause light sphere A, B, and C values because that's what I'm passing into the light functions in the draw, and I'll show you that in a bit. And those are the point lights, obviously. Other things like the camera, controllable camera, stuff like that. Then in draw scene, we basically have this. I'm drawing. I'm then going by shader. So I draw everything that's it's an arbitrary decision, but I chose to just render the color stuff first. So I set that to context. I set the point light values with these pause light sphere A, B, and C things so that gets updated and the lights rotate around with the objects. And then I render the objects that are under that color shader. After that, I do the texture shader. It's the same deal. And then I render those. I render the terrain after that because the terrain uses this shader. And then the skybox, which uses its own shader, the texture shader, just the regular unlit texture shader. Yeah, we send the light parameters and then we tell it to render, and that's it. And that's it for like most of DXApp, and then the rest is just the internal stuff. So moving on, let's do the skybox class. So here I have an actual class for the skybox. It kind of functions just like a graphics object. It has a reference to a shader, the shader texture, and then a texture. So when you make a skybox, you pass in the device, the D3D device, because it needs that. You pass in the shader, you pass in the texture, and then a size value for the scaling of it's the size of the skybox. So let me just go up here. You can see where I'm setting that up. I pass in the device, the shader text skybox, the texture, and then 100, which is the scale of the skybox in my scene. Sorry, whenever I talk for longer than like 15 minutes at a time, my voice just completely fails out. And I start coughing uncontrollably. It's a bad time. So the reason why I needed the device is because the Skybox handles its own model. But in order to create a model, you need that device. And the only way to get that is by passing it through DXApp. So that's something that was just necessary that I had to do. We just store the references to the shader, the texture. Then we create the world matrix, which is just a scale matrix with that size repeated, because it's a box. It's just supposed to be a box. It's not supposed to be scaled like in any fancy way. It's just a box, a cube. We delete the model at the end. Then I have a function where the user can reset the size whenever they want. And then render is like a graphic object render. It sends the fog parameters, binds the buffers, goes through the meshes. Doesn't really need to do this, but this will only happen once anyway. So we send the world, we set that to context, set the texture to context, and we render the mesh. It's exactly how you would expect a graphics object to work. It's just contained in a Skybox class. So that's how that works. Yeah, the Skybox pre-made model is an inward cube. Forgot to mention that, but I mean, it's obvious. You saw the demo. Let's see. Yeah, you specify that. It takes care of its own rendering. Yeah, so that's all of that in the Skybox class. Onto the terrain class. This one was cool. I don't know. Terrain is like a graphics object, but it also handles its own model creation, passes all of that in. It's got a really long but necessary constructor here where I pass in the device, I pass in the shader, the texture, kind of like the Skybox, because now this is a graphics object, so it handles that. It needs references to the shader and texture so that it can handle its own rendering. I've got a render function here. You specify a height map file path, side length, the zero height, the max height, and then the UV repeat values. So let me just show you how that's done here. I'm passing in the device, passing in the shader, the texture, giving the path to a Targa like height map file, telling it that I want it to be 60, have a side length of 60 units. I want the zero height to be -4, so it's going to be -4 on the y axis. And then the height map height is 2 units, so it's kind of like constructed, scaled up almost, but it's not actually scaled. You can see here I never actually, the world matrix is always identity. It's the identity matrix, so I never scale by the world matrix. I scale the vertices. So there's that. So this handles everything with terrain. It loads the Targa file, the height map file, does all of these calculations for the UVs. You can see like the UV repeat values are here, side length stuff. The height is calculated with the zero height in mind, as well as the max height as well. So it does all of this correctly. It works really nicely. I do the triangles here, I calculate those, and I calculate the normals, the face normals, with that cool fancy calculation stuff, averaging them out, summing them up. I normalize those normals, yeah, all of that. This handles its own model, so I delete that model, but it doesn't handle anything else, so that has to be handled elsewhere. I'll show you my delete in the DXApp just to make sure you got it. Have these some helper functions, and then my render function, which is same as Skybox, same as graphics object. It sends the fog, binds the vertex index buffers, and then does the correct order of operations for shader, texture, and model rendering. So basically, to use a skybox and use a terrain, all you have to do really is create them in your init, which is just one line. It's like these two lines here, and then you just have to draw them, and that's it. It's 2 lines to be able to use terrain and a skybox, which is cool. Here I'll show you my delete function, so I just delete all of the textures to show you that I'm handling all of these things in the DX app. So the textures, the models, the shaders, the graphics objects, skybox, terrain, all of that. I release my COM objects. It's all nice and clean. It's good. So let me just make sure I got everything here. Yeah, I mean, you saw the texture. The vertices, the normals, stuff like that. I'll show you the demo in a bit. Graphic object class, I went through that. Yep. Cool. So yeah, that's all about that. Code practices will be up to you, I think. Let me just show the demo once more, just to confirm everything is correct still. So this is just everything that I just talked about in action. I think that's pretty much it, honestly. I'm gonna just quickly look through some of these files here to make sure I got everything. Got all the graphic objects, the DX app stuff, shaders, models, all that good stuff. Texture class, which you gave to us. Camera tools, which you gave to us. Yeah, that's pretty much it. So cool. I think I'm gonna end my video there. Thanks. I'm coming in around 32 minutes, which is about what you wanted. Cool. Alright, thank you. Bye-bye.